So welcome everybody. This is the September 2020 meeting of the Scicloj group. We are interested in the mix of data science and Clojure. And today we have a very interesting meeting. And we will first start with Daniel, who will discuss the state of the art of the machine learning ecosystem in Clojure. Afterwards, we will switch to Kiran. Is that correct? Well,
yeah, that's
well
right.
pronounced.
Yes.
We will talk about Weka, a machine learning library for Clojure. And then we will switch to Anthony, who will discuss how to make Spark interact with Clojure. And finally, we will have some discussion afterwards. Those who wish to stay can stay after the official time. We have a time, we have a 90-minute limit for the whole event. That includes every talk by the speakers, which should last 15 minutes, plus 5 minutes for questions. So, Daniel, whenever you're ready, we are.
Oh, thank you. So I'll share my screen. Can everybody see my screen?
Yep.
Yes.
Yeah, wonderful. Okay, so what I wish to do in the following few minutes is share my user experience with the current stack of machine learning libraries in Clojure, and maybe ask some questions. And I guess maybe since we will have 3 talks about different aspects of machine learning today, it may be good to somehow say what it is about. So what I'm going to tell now is kind of my mental model after learning from the existing libraries. And that is how I try to understand things. And the idea is as follows. We have data. We have data, and we wish to train our machine to learn from the data. And in the current context, I will speak about what people usually call regression problems, where it is actually about prediction. It is about learning from data so that we can predict something for future data. And let us have some pseudocode that tells the story of prediction. So assume you have some data that you're learning from. Let us call it training data. Right? You train your machine on the data. And usually you have a certain pipeline of operations. First, you go and do some cleaning of the data. And this cleaning usually depends on some parameters like thresholds and such. And you may discover these parameters by some exploration of the data. And then you have some other preprocessing. Maybe it is about adding columns to your table by certain data transformations. And again, it may depend on your exploration and on more parameters. And then you have this step that is called usually training, where you have a certain algorithm. It can be a decision tree or something with many decision trees, something of the world of machine learning, and you train your model and you create a certain object that knows how to predict. And then you can ask that model what the predictions are for the training data so that you can measure how good it is with the training data. So that is very schematic. That is very high-level pseudocode. And the idea about this pipeline is that we can think about the model as everything we discover through the process, including the parameters we chose, including certain statistics in the intermediate steps, including everything. So the resulting object knows everything about what we have gone through. And then we can use that model and test it with more data. But this time, everything we do in the context of already knowing the model. So for example, if at the pre-processing stage, we were computing some statistics over the data, then this time in the test data, these statistics are already available to us. So we do everything in the context of knowing the model, knowing everything that has been going on in the training phase. And then we can get the model predictions for the test data. Sorry, this is not necessary here. And then we can measure it on the test data and see how we perform. And then further, we can deploy the model and actually use it for real-time, real-world data after we have tested it. And so this conceptual, really high-level, confused way of seeing things is what I got from learning the existing libraries, and mainly tech.ml, the library for machine learning that Chris has been working on. And now we can ask, can we have all this process? And can we have it with a beautiful grammar, with good performance, and with all the features that we may like to have, like having it really easy for beginners and being able to analyze the performance of everything and check many variations and optimize over parameters, and also serialize any object that we create and deploy everything easily. Can we have all that? And the tech.ml library that we have learned about in previous meetings, it gives a decent answer to most of these questions. And from my experience in the last few days, it is just almost there. And we just have to think, I think, how to proceed from what it has already achieved. So let us maybe look into some really, really quick example. And in this example, I will be looking into taxi trip durations data in a Kaggle competition by a username called Beluga, who has done a really nice Python tutorial for a solution of the prediction of taxi ride durations. And the libraries we will be using are these. These are Smile by -Lee, which has lots of machine learning algorithms, and actually XGBoost too, which is a separate machine learning library, and Fastmath by Tomasz, who has lots of mathematics and machine learning and clustering algorithms that we'll be using. And also all the tech stack of data type abstractions and data frames, and tablecloth, which is a nice grammar around the tech stack. I guess most of us already know these libraries, but just had to mention that these are being used in the current example. Any small questions so far before I proceed? No? Okay, so let us proceed. So we usually begin by getting the data and splitting it to certain training data and test data, as we mentioned before. And then we can look at the data and explore it and see if there are any problems. And I'm skipping most of these details since most of them are not so much surprising. And then eventually what we have by the tech.ml philosophy, which is the philosophy of the tech.ml library, we have a certain pipeline where the data set goes through a long process of data transformations. Some of these transformations are possible to do only in the training phase. So there is a certain construct that allows us to do it only in training. And that is relevant, for example, in cases where we have columns which are available only in training data. And through all this process, we may accumulate certain metadata. For example, we are using certain clustering methods by the original tutorial that I mimic. And this clustering method, what it does, it adds a certain column that matches the location in the city to a certain cluster so that we can have some notion of locality. So this clustering is done on the training step. So we cluster all the location in the city into places. And in the test step, in the test stage, we already have this clustering information. We do not want to do the clustering again. So this is done through metadata, and it is actually a really neat idea, I think, of the tech.ml, maybe the central idea. And here I did it in a kind of explicit way, which is a little bit verbose, maybe adding the clusters to the metadata. But tech.ml provides a certain set of macros that makes it much less verbose. I just didn't want to include them for clarity. And then we can have a processed training set and a processed data set. And when we create the processed data set, we do it with the context of things that we have learned in the training set. For example, we look at the location of the pickup where the taxi picks up the passenger, and then we cluster it. So the certain cluster, which matches kind of a neighborhood in the city, it is being able to recognize it is something that we learned in the training data. And so we process the test data using this existing context. And then it is really fun actually to use both tech.ml and Fastmath, the library, and the tech.viz library that allows for these neat histograms to look into the data, to look into the processed data. And for example, here is one column that we will created in the pre-processing. It says, based on your location around, what speed is expected for the trip, for the taxi trip? So you see there is some pattern, visual pattern, and we see that this pattern is actually quite similar in the testing set and trace set, which makes sense because they were sampled from the same data. And then eventually we can train a model. And for this model, what we do, I just sampled some part of the training set to have it quicker. And then I used XGBoost. And you see the grammar of tech.ml is really nice in these details. And it is really actually much cleaner than the Python story that I tried to mimic. And then we can predict using this model. We get predictions and we can see how bad these predictions are compared to the actual data, which is, in this case, the median average error is, the median absolute error is about 300 seconds, which is not so good, but relatively to the durations of trips, it is decent. And we see that it is similar in testing and in training, which means that we don't have the overfitting, so to speak. And then we can scatter the actually predicted trip durations in the test data and see how they compare to the actual trip durations. And we see that there is some connection. So this was some flow, and that is how the flow looks. And I just wanted to give the taste of it and just say that I'm amazed by what there already is in the stack. And what I learned from Chris in the last few days is that maybe the main idea here is being able to have a certain notion of pipeline, like having everything as a sequence of operations. And you see some of these operations are using the DSL of tech.ml, and others are using the tablecloth library, which has a nice grammar for data processing. And this this pipeline has this magic that knows to behave differently in training and testing. And it keeps the context of training so that everything flows. And this, I think, matters a lot. Having a clean way to express ourselves matters a lot, because in machine learning, you can have really subtle errors, really subtle ways to be confused and to have a mistake that makes you believe you did a good process, but actually you may have been lying to yourself. And it is really easy to have these kind of errors if you don't have a clean process to reason about. So I think here it really matters a lot. And looking at the Python code that I had to mimic and looking at the resulting Clojure code, in my beginner experience, which is new to these libraries, I see the Clojure code is much cleaner. And I think I'm really optimistic seeing how it looks at the moment. And what I hope that we can do is keep thinking about how we grow this stack and connect to the stacks that Kiran and Anthony will be describing in the 2 other talks. Now, hopefully we can have some beautiful grammar wrapping all this, and so that we can have this nice user experience. So this was my confused user experience of using existing libraries of Clojure machine learning. And thank you for listening in. And I would love to discuss further. Thank you.
Wow. Great, great, Daniel. Great timing, actually. You still had 1 minute to talk.
Oh, wonderful.
Now we have 5 minutes available for questions. So if anyone has something to ask Daniel, then this is the moment. This is the time.
I just have a quick comment. I thought it was a really great introduction, and it really helped being away for a while. It really helped me understand what we were doing. So thank you very much for that, Daniel. It was extremely useful. Thank you. And not at all confusing either.
Hey, Daniel, quick comment again. Thank you. That was a really nice introduction. I've been working on trying to use MXNet for the past few days, and it's been really frustrating. So one of the things that I've been battling with is all the prerequisites for actually being able to use the libraries. So what are the prerequisites for the things that that you just showed us using tech.ml and Smile and all that? What underlying Python libraries or other libraries do you need to install?
Oh, yeah, thank you for mentioning that. So here we were not using any Python libraries. We were using mostly the JVM, except for some small parts which use native libraries behind the scenes, but it was mostly a JVM story of Java libraries which are wrapped in Clojure. And maybe I'll mention, because you mentioned that, we are currently thinking about creating a certain learning group where we learn together. And that follows actually your comments, Sivaram, in the previous meeting, that we wish to learn together. So let us one day meet up and just play together with these tools and libraries.
No, I will really appreciate that, because last couple of days I've been trying to use MXNet, and so far I have not been able to, in spite of trying to compile MXNet from source and installing it, not been able to use the Clojure tutorials to work at all on MXNet. So that's one of the things. So it's really awesome to see that you're able to actually just import these libraries and get them to work. Everything works like magic.
Yeah, at least that is how it felt. And I haven't mentioned Fastmath so much in this process, but behind the scenes, lots of mathematical computations like the clustering and other parts were being done by Fastmath, which is just a huge collection of neat Clojure wrappers for existing Java libraries for math and statistics and machine learning. And yeah, and it just works.
All right, great. Thank you.
someone else to ask Daniel something?
Yeah, I had a question. Daniel, great presentation. My question is really, from your presentation, it's not obvious how many different libraries you used for the data pipeline, and you mentioned a couple of them, right? So obviously, you felt the need to use multiple of them because one of them does not, solve everything. So perhaps it's useful to have a high-level guideline on what are the capabilities of say library 1 versus 2, and where do you need to use both, because when a beginner approaches this, they're looking sometimes for the shortcut, just import one library and everything works, and it becomes a bit unclear when they need to use something else. So it's not a comment on your presentation itself, but it would help a beginner if you can guide them on what library does what well so that they can pick one.
Yeah, so maybe I'll just for a moment share my screen again and let us look into it, if it is okay, Leandro. Yeah, thanks. So let us look at the collection of libraries that I've been looking into. And of course, you, Kiran, will add another part of the story, which is not here. And Anthony will add another one. So here, for me, the main part of the everyday libraries that I'm using. And so Smile is just a collection of algorithms by -Lee, both supervised and unsupervised machine learning and statistics and other mathematical algorithms. And Fastmath is, in a sense, similar. It is just a huge collection of mathematical algorithms, and both have a Clojure API. Mainly Fastmath is very friendly for Clojure people, and it is really likely that if you need some math or statistic function, you will just find it at Fastmath. And tech data type is maybe the important piece here of everything that glues everything together, and it provides a certain infrastructure upon which you can build and connect all your stack. And it is mostly about what people usually call array programming, that is having a certain notion of array, even though it is called a bit differently in tech data type, and being able to work with them and connect different libraries that are speaking in terms of arrays of data. And I think the fact that things connect well and can be glued together nicely, for example, that the tech.ml data frames can be translated comfortably to Smile data frames so that we can use Smile with tech.ml. All these details are there mainly thanks to tech data type, which is the fundamental part, the way I understand it. And tech.ml dataset is a really detailed library and a really performant library for data frames, that is tables of data. And tablecloth is a nice wrapper around it. So you can use two different grammars, the one of tech.ml dataset and the one of tablecloth, a matter of taste, I guess. And you can express yourself in two different ways, if it makes sense. And tech.ml is just about gluing this into a machine learning context. And most of the details of the pipelines we have been seeing actually come from here, from tech.ml dataset, but tech.ml does put it in the context of machine learning. And Chris, the author, is here in the audience, and maybe he would like to add more about this context. And I hope it helps. And yes, I agree so much that we need some additional layer that will make things clearer for beginners. And that is not there yet, in a sense, but I think we are going there.
Got it. Thank you.
Thank you very much, Daniel, for your time. If
Sorry, is
someone
there time
has
for one more?
questions for Daniel, I would kindly request that they will have to wait a little bit, so we don't get late with the rest of the schedule. They can ask the questions once the rest of the presentations are finished, if it's okay with everybody. So now I will ask Kiran to give his presentation. Kiran will talk about Weka and how to use it through clj-ml. Please, Kiran, whenever you're ready.
Thank you. Can you see my screen?
Yes, 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 yes.
Okay. So today I'm going to talk about Weka and clj-ml, and it's a slightly different take on the machine learning ecosystem. I hope you enjoy it. About me, I go on GitHub as SharkHitMe, and I've been programming for a long time, and I've been involved with Clojure since the past 7 years. A lot of it has been in the data science space. I work from Singapore, and in the past, I have done small contributions to data science libraries in Clojure. Ones that I remember are co.matrix, Sparkling, which was one of the, I know there are 3 wrappers of Spark in Clojure. Sparkling was one of them. And I worked a bit with Cortex, which is done some contributions to Cortex, which is a machine neural network library that Chris was leading a couple of years back. So I get an interesting perspective because most of my work was, say, between 2016 and 2018, and then again in the last year. And it's interesting to see how much has changed in that time as compared to, today. So my goals today are to talk about, first of all, when and why should you consider using Weka and clj-ml? I think from a practitioner's perspective, what happens when you look at any language or any ecosystem is that there are many ways of doing something, and it's not very clear why you should use one versus the other. And that's going to be the main crux of my discussion today. Then I'm going to do a very quick dive into clj-ml itself, and then talk about suggested usage patterns. What is the best, not best, but what I've felt is useful. So before going in, I think it's important to understand that often you work in teams where you don't have a great deal of choice in terms of the tooling. So you might be working with somebody who's good in Python, who's good in R, and who can do a lot of things. So there's a certain amount of pressure in terms of justifying why you're using Clojure and any other machine learning libraries, right? So this is, I'm talking in production, of course, when not when you're, say, just trying out a library. So what inevitably happens is that you'll have somebody who says, why don't you use Python or R or Azure ML or something like that? And this has been my experience. Of course, it may not reflect with all of you. And having worked in such projects in the past, I have seen that the visual tools that exist for machine learning have made tremendous progress in the past, past few years. And now they're getting to the point where somebody who's familiar with these tools can get started very quickly. And it makes it difficult to really compete with them, in the sense that, how can you get started so quickly when you create your new machine learning project and slurp in your data and create some charts, and that takes a bit of time, especially if you're if you don't have all your libraries and if you don't have a great sense of what tool to use where. So I feel that these are 2 different sort of perspectives on what tooling works and what should you use. And I don't know if how many of you are familiar with these tools. RapidMiner, for example, is in terms of popularity, probably the second most popular tool in machine learning. And I know for a fact that there are PhDs in machine learning who actually prefer to use RapidMiner because it can be really quick. So I struggle with what should I use sometimes, and I reflect on this thing that Larry Wall said, which is that this is a long quote, which basically was meant to say that Perl is meant to make easy things easy and difficult things possible. And sometimes the GUI tools versus the code tools, they offer very diametrically different options. So the GUI tools are good for some things. They're good for quick data exploration. They're good for building and evaluating models. Some of them can even do deployment. I think Amazon SageMaker comes to mind. On the other hand, the code-based tools are very good at data cleaning and building pipelines. Data cleaning can be done by GUI tools, but it is somewhat painful. Like you can't do it as well. And if there's something missing in that library, you really have no way around it. But let's not forget that in a machine learning project, often data acquisition, cleaning, and processing takes roughly 80% of the time. Now, this is a very generic industry quote. I have found that most of the time this figure is close to 90 or even 95%. So, so technically, you want to be in code as much as possible. But when you can, you should be able to jump to a different tool, and the interworking should be, should work. So what I feel is the ideal tool chain should enable anybody to switch from code to GUI to code seamlessly. And some of the functionality that you need is importing of data and exporting of trained models. So having said that, let's look at where I found clj-ml to be useful, and how I've worked with that in projects where I had to do machine learning. So in terms of a sweet spot, in true data science fashion, I think there are three sort of dimensions that you want to consider. And one dimension is role, where if you're in a project where you want to do machine learning, and the role that you have to handle is really the full stack machine learning engineer, where you're doing all the data extraction, data acquisition, say from Kafka and database and any number of sources. You're building a data set. You spend some time looking at the data, then you train a model, and then you have to deploy it as well. So this is quite different from a traditional data scientist role. In some organizations and some teams, data scientists get very lucky. They get a very clean data set, so they just have to do model tuning, and that's all they do. And this is, of course, it could be true for domains, very specialized domains such as audio and video, where indeed the data is what it is and there's not much more processing. It's just, improve the model by a little bit is what's done. However, in most projects I've worked in, it's low dimension data, and that's not the case. So it's mostly what I call full stack machine learning engineering. The second is you should be comfortable with using multiple facets of these tools. So you should be comfortable with using a GUI or a CLI or a library based on what's needed. And third, of course, because you're a Clojure programmer, you want to build a data pipeline in Clojure. And in terms of data, the sweet spot is the data should be low dimension data. So not images, not audio, not video. clj-ml and Weka, they work best with traditional models, that's non-neural network models. They do have support for perceptrons and integrations with deep learning for J. However, that's all said and done an extension. And for most models, the data should fit in core memory. There's a star because you have a couple of ways around it, which involve some hacking. You can use memory map files like the arrow work that Chris has been doing. And you have certain classifiers called incremental classifiers, where you can save and load and retrain, even after, serializing the model specifically. And the third aspect that I just got to know of today is that Weka is GPL licensed. So if it's a product you're building and you have to ship it, you might want to consider that Weka is GPL, and therefore, can you really, how does it contaminate the license of the rest of your product is something that you should know about. I'm not qualified to comment on that. So let's look at Weka now and what it is. So Weka is a machine learning toolkit written in Java. It's one of the oldest. Its development started actually in 1997. That makes it more than 20 years old now. And it is still actively maintained. It's gone through some ownership changes. It has two branches, a stable and a development branch. The stable branch was actually released in last year, and the active branch is actually actively developed. It has interop with R, Python, and Spark. And it also has a very active extension community. So as an extension, you can develop a new model, a new algorithm, and provide it in a specific API which can be loaded into Weka and used. And in terms of resources to learn, there are at least 3 online courses that you can use to learn Weka, and there's a book, there are lots of forums. As a side, you might observe that the book is called data mining, which is sort of this old school term for machine learning, which somehow many people don't use nowadays, but that's how old it is. And if you actually start to learn about Weka, you'd see that a lot of the messaging is around the visual interface, which can probably put you off. You might think that it's only a visual tool, but that's not the case. It's got 3 interfaces, a GUI, a CLI, and of course, either Java or Clojure libraries. And I find it quite useful because these interfaces support 3 different audiences. The GUI supports an experimentation kind of audience. The library supports data pipeline development, and the CLI is really useful for DevOps. So if you've got a trained model and you just want to orchestrate it using Docker, you don't really have to build your own little wrapper on top of a CLI wrapper on top of that. How much time do I have left, may I ask?
Don't worry, you still have 3 minutes.
Okay. Okay, so I'll go a little more quicker. So clj-ml is a wrapper on top of the Weka's Java library, and it's got, from a high-level perspective, it's got 3 main buckets. One is I/O. You can use multiple different kinds of files. Some of these are old school ARFF formats. You have a second stack for feature selection and dataset and feature transformation. To be honest, I don't find the feature transformation one very useful because you can do a lot of that in Clojure, in vanilla Clojure. And 3, you have a bunch of algorithms, classification, regression, clustering, PCA kind of stuff. So if you look at the list of supported classifiers and regressors, it's a lot. And frankly, this is a small subset of what is actually present in Weka itself. And it's really straightforward to add new classifiers. So those of you who are, very much into machine learning might observe that, yeah, I see XGBoost missing, which is a fair observation. XGBoost is available as an add-on package. Doesn't yet exist in clj-ml itself, but it's really 5-10 lines of code to put it into clj-ml if you absolutely need it. So I'll jump through what I call usage scenarios, which is a textbook usage of how somebody would want to use clj-ml and real world usage. So in terms of classification, I've really just copied this from the README, and it is really straightforward to use. You can load data from a classifier, from a file, CSV, ARFF, whatever format you need. You indicate which is the target variable. In this case, there's one column named class. And then you can create a classifier by passing arguments. In this case, you can say decision tree, and C45 is one variation of a decision tree. You have a few more of them, and you train it. And you can use the same trained classifier to basically classify an instance. Fairly straightforward. You pass the classifier and you pass an instance, a single instance. And you get, in this case, we're using the iris data set, you get a predicted class for it. And evaluation is, again, fairly straightforward. You pass a classifier object and a data set, and you specify how many fold cross-validation you want to do, and it will return an evaluation object which contains a bunch of statistics which are relevant for that task. So if it's regression, you might not get correctly classified instances, you'll get something else. What I find useful is to think about how you would use this in a real project, and looking back at my efforts, I found this is what I do. So I generally start by creating a data acquisition namespace which acquires data from multiple sources, such as Kafka, database, stream sometimes, file sometimes, and I create a data set, an ARFF or a CSV data set, and I constantly transition between the Clojure Emacs, for example, and the Weka GUI. So I would do the data exploration in Weka. I'd look at, say, correlations between features in Weka. I look at which features are important. So Weka allows you to basically look at a data set and say, rank the features in terms of importance. And there are 12 different ways in which you can do that. And then I might jump back to actually create a data set with more features. And of course, all of this is iterative. And at some point, I might use the Weka experimenter. So the Weka experimenter is a way to create multiple data sets and compare its performance on multiple classifiers or regressors. So it's an M cross N matrix. You can also use it in lieu of AutoML. I'll just address that. And finally, from a project perspective, once I'm familiar with which classifiers are doing well and what is a data set that's working well, I'll jump back to model training and fine tuning in Clojure itself, and gradually I will stop using the GUI. So the experimenter, for those who have not seen it, is a GUI tool where you can provide multiple data sets. Here there's just one, and you can test it on multiple algorithms. You can choose to repeat it, have separate train and test splits, or you can have randomized cross-validation, all of that. Alternatively, you can use AutoML. So Weka has got a AutoML package. I'd advise you to read this paper. Before that, there's an AutoML evaluation, which basically says that, I'm not sure if I can quote it exactly, but that AutoML does not, with Weka, does not work as well as, or works about as well as somewhat tuned random forests. So your call if you want to use that. And over time, okay, how much time do I have left now?
1 minute left.
Okay. So over time, on an effort scale, basically my work stays in Clojure, and I use the Weka GUI less and less, and all of my work, model tuning, model deployment, model validation, all of that happens only in my Clojure and Emacs workspace. And if it helps, there's an additional small tool that I wrote that basically helps you transition between the code.matrix datasets and the clj-ml datasets, because they are different formats. And if you're familiar with code.matrix, you can do a lot of dataset transformations in that. And that's it. Thank you.
Thank you very much, Kiran, for your time. Since your talk is very similar to Anthony's, and since you took a little bit longer than was expected, I think it will be also very useful to have the questions related to this talk after we hear Anthony's, so we can compare both libraries and both Clojure wrappers.
Sure.
As I said, now we will hear Anthony, who will talk about how to use Spark and Spark.ml through Geni. Anthony?
Sure. Let me show my face. Hi, everyone. Let me share my screen, if I could. Okay. So I thought today what I'm going to do is share with you how I work with Geni on a daily basis. I spoke about it in the last meeting where basically, in summary, it's a Clojure data frame library that runs on Spark, right? It's a Spark wrapper, but it has its own grammar kind of thing. So today I'd like to do a live demo, which is hopefully nothing goes wrong, fingers crossed. And the objective today is to show you the kind of fast REPL feedback that you can get with Geni, right? It's the important thing is not so much what we do like with the data in this session, but note the number of evals and the query speed that comes with it, right? That's what I want to show. And secondly, I want to sort of dispel this myth that Spark is only for big data, right? Because it's I think even for a lot of power users in Spark, they say this, but really. I think it's amazing for small data too. So caveat, don't take any of this seriously, please. I'm gonna be using some free data on Kaggle. And yeah, if I, can everybody see my screen? Is that okay?
Yes, until a moment. Yes.
Yeah, okay, cool. So basically I've got those two CSV files, right? Maybe not cat. They're like some pretty much what you expect, right? And in order to work with this, the first thing I'm going to do is fire up the Geni CLI, right? What that's going to do is going to step you inside a Clojure REPL, and it's going to require all the Geni stuff for you. Basically you can just connect via here the nREPL through your text editor. So on Kiran's note, about requiring multiple libraries, this is the ultimate shortcut, right? You're going to require 0 libraries with this. So you can play around with this. It's pretty much what you expect, but I'm going to connect to the nREPL session with the text editor. I use New, Vim, and Conjure. So I just like having the REPL log on the right-hand side, right? And I'm going to start loading the data. Again, no requires. It's been required for you, and just doing that. That's the Spark data set, right? And you can pretty much do whatever you expect a data frame library to be able to do. Count is the number of rows, right? Shape is number of rows and columns. Print schema is you'll see the columns and also the types and whether or not they're nullable. And if you've been using Spark, this would look very familiar to you, right? But since we're in Clojure, I thought it'd be nice to work with columns that are in kebab cases, right? So we can do that with kebab columns, and they'll just rename the columns for you. We can have a look at the data, but if we do this, you can see that it's the output is a bit truncated, so that's not very nice. So we can do vertical instead, right? And we'll be able to see the data more clearly. So it's only showing 20 rows, and we see that invoice, stock code, they're just numbers, and description is just a bunch of words, and the other stuff pretty much what you expect. So I think I'm done with that. I'm gonna call that invoices, all right? Just gonna evaluate that. And I'm going to do some exploratory data analysis, right? And the first thing, whenever I get a new data set, first thing I do is I want to check whether or not any of the columns represent like the primary key, right? Like there's a unique value for that column, right? And my first guess is the column invoice. So what I'm going to do is I'm going to do invoices, if I can type, invoices, and I'm going to do aggregate count distinct invoices. Sorry, invoice. And I'm just going to show, show. So we said that we had like a million rows, but then this is only 50,000, right? So that's not quite that column, right? But what we can do is we can also count distinct stock code. Maybe that's the one. So there's only 5,000. So that's not really the one. And we probably don't want to type all the columns in. So one thing we can do is just map G columns of invoices. Something we can do. So that's going to grab all the columns, but that doesn't look nice. So let's do vertical instead. So we see that none of the columns are really the primary key here. And that's okay. What about combinations, right? Count distinct, struct of invoice and let's see, stock code. Let's see. So we see that there's a million things, right? So that's probably close to the primary key, that combination, right? But as it turns out, this data contains duplicates. So if we do invoices count, we'll have 1,060,000 things. But then if we do distinct count, we'll have 1,030,000 things. So we can just go back up and see, let's just drop duplicates. And I think we can, we'll say that's okay. So next, I want to look at this column description, right? The description column looks interesting. In particular, I want to see what description is the most common one. So we'll select that, and there's a really nice pandas idiom called value count, which I really like using. So that's just a shortcut to tell you, hey, that's like white hanging heart tea light holder appears 5,740 times. So I see that on the third entry, there's null. So I'm just going to remove that. Again, Clojure idiom, remove null description. And we'll eval again and see, okay, so that's been taken care of. But maybe I don't want to look at the description, right? I want to look at the descriptors, like the actual words that make up the description. So the first thing is to sort of just split out the word, right? So that's the tokenizing operation. And we can borrow something from Spark.ml. We'll say transform tokenizer output column, input column is description. And then output column is descriptors. And then if I show again, we can see that here there's wooden picture frame with white finish, and then we'll get an array instead of the sentence. Now, instead of having every row being an array of descriptors, I want every row to be an element of the descriptor, right? And so that's the explode operation. So we can say with column descriptor, which is the explode of descriptors. So we can do that. So if I get rid of this and show you the count, it should tell me 1,000,000 something. But then once I explode it, we should get like 4,000,000 something. So that every row on average has like 4 or 5 descriptor words, and now that's been exploded. And I can go back again and say select descriptor and value counts and show to see what's the most common descriptor, right? we can see that, okay, bag is very common, set is common, but off is maybe something that we don't want to see there. It's not really a description. And there's the empty string there. One thing we can do is let's just remove all the length that's less than 3, let's say. Okay, let's keep evaling. Okay, so that looks a bit better. So there's bag, set, hard, pink, retrospot. Sounds like descriptive words. So that's fine. At this point, I think you kind of get the idea of how Geni allows you to get started very quickly and also be able to iterate through different ideas very quickly as well. It's designed so that it's short to write, right? And it has a lot of these idioms. So at this point, I want to go to another script that I've made. Basically, the first two is the same as before, with a little bit more cleaning step. And maybe what I want to do with this transaction data is that I want to do a recommender system, right? I just want to train on a collaborative filtering model, just like in the Netflix challenge, where you have members, movies, and their ratings. This time around, we'll have these descriptors, and we'll have the customer ID, and we'll have their spending. Here, I'm going to be using the log spending, just so that we don't work with heavy-tailed target distribution. And again, this is just a bit of fun, right? Like, I'm not seriously suggesting that this setup would be useful, but that's fine. And we're going to define a pipeline. The collaborative filtering model that on Spark is called ALS, or alternating least squares. It expects numbers of IDs, right, instead of strings. So that first we need to convert the descriptor, which is a sentence, to descriptor ID, which is just going to be a number. And there's a nice feature step for that on Spark as well. It's called the string indexer, and we can chain these two stages using a pipeline. What's going to happen is that during training, you'll pick up all those descriptor and assign it a number, and then during test time, you remember what the descriptors are and what corresponding numbers will be assigned to. And here I'm going to fit, and I'll be able to take, once the model is fit, I'll be able to take the last stage, which is corresponding to the alternating least squares model, and then I can do some item recommendation. And I'm going to do all of that now. Let's give that a go. Yeah. So just to show that I'm not bluffing, right? Like, this is really training, right? It's using all the cores. It's going to take a bit less than 1 minute. The data frame, I think, contains 800,000 rows. So it's considered to be, Spark is pretty performant that way. And we'll just let it finish. There you go. It just dies down, so that's finished, right? What I want to show is this, right? Recommend items. Oh, excuse me. I need to define the ALS models. And now we can just do recommend items. What that's going to do is that for every customer ID, it's going to recommend a descriptor, right? So maybe this customer ID likes red, and then we're going to recommend bags and lights as well. Who knows? Again, it's not meant to be useful. It's just an illustration. But what we're saying here is that recommend 3 items for every customer ID, right? And the final thing I want to do is that you can do collect. So collect is going to transform everything into nice Clojure data structures, right? So that you can plug it into other parts of the code, other components, right? What you're going to get is a sequence of nested maps instead of a Scala sequence of Spark rows, which is maybe less useful. So I think that's my 15 minutes, and I'm going to stop here. Thank you for listening.
Wow, that's awesome timing, Anthony. Thank you very much for your presentation. It was very hands-on presentation, which is awesome and cool to see. I'm really looking forward to become as proficient in Spacemacs or Vim as much as you are. That would be like, wow, really great accomplishment. We will now take questions for both Kiran and Anthony's talk. Since we pushed the questions for Kiran's talk, I would like to start with those. If somebody has questions for Kiran, this is the moment to ask them.
I believe there's a question from Sivaram on the chat.
Yes, but it's related to your talk, not to Kiran's.
Oh, sorry, excuse me.
Oh, it's okay. Yes, Daniel.
Yeah, thank you.
Go ahead.
It was really enlightening to see both stories and really to see what a Weka workflow looks like today and what pieces are taking part. And I wonder, Kiran, if that is okay, could you tell a little bit more about your experience with the GUI, with the graphical user interface? What may be missing there for you? How does it connect to the Clojure REPL experience? Because you have two different dynamic tools you're using. Do they connect actually? Is there any dream about how it could be?
Okay, so perhaps not relevant to Weka alone, but some of the new age tools, I think, let me not name specific ones, but they have the ability to see visualizations out of the box and like a REPL box at the bottom, something like RStudio. I wouldn't know if it is worthwhile actually trying to connect, because it appears that these are two different audiences, the kind of people who want to work with the REPL as opposed to somebody who wants to work with the GUI. And frankly, Weka also has the ability, just like RapidMiner and Nime, to actually build the whole pipeline in a GUI. So you don't ever need to use a REPL. I think the value of the REPL or in code comes from doing complicated data processing as well as getting data from sources where it is not very straightforward. And that's the value, that's what I believe. But again, that's my personal experience from low dimension data, which may not be true with high dimension data.
All right. Is there any other question for Kiran?
Not a question, but a comment I want to make.
Sure, please go ahead.
Kiran said, I think I would like some of the names of the tools to be named actually, but also if you are developing any GUIs, graphical tools, I think it would be really good if you have a small area at the bottom or somehow where you can actually see the commands that are being run. It's kind of like how some of the Git things work, where when you are checking in or checking out or syncing and doing all the different actions using a GUI tool, you can actually see what commands are being run and all that. And I think it's useful when you are trying to make the transition from a graphical tool to a code-based workflow or pipeline, right? When you're building up, you know where to step in and do something custom if you want to replicate that. So I think it's a useful thing. Now, not everybody will need it. So again, like how Git does, and maybe even the Linux installation process does, where it's typically by default collapsed, and you can expand it to see what commands are being run. So something like that would be a good balance, I think, from a from a developer versus an end user perspective.
Right. So the only tool that I've seen does this is one called OpenRefine, which is a slightly older tool that was open sourced by Google, and then Google went ahead and built a better version of it that is not open source. And OpenRefine actually uses can let you use Clojure and Groovy and I think some other scripting, but it's not really code, as in it is a JSON structure, which is written as a log that you can actually rewind and replay. So it's not as crisp as, say, a Clojure form. But that's the closest that I've seen.
Okay. Yeah. Yeah. It was just a comment. It is, as some of you are developing GUI tools, something that would be good to have.
Right.
Is there any other question for Kiran? Because I have one actually.
I kind of.
Yeah, sorry. Please go ahead.
Yeah. I kind of have a question or comment rather. Like, as in, this is coming from someone who is trying to explore like the data science libraries as a beginner. Then when I understand that Clojure tends to have a lot of like libraries that seem to be like they stop development, but they still are they are still definitely usable. But so when I saw clj-ml, like when I saw the last date of update being 2017, I was like, oh, this is probably not being used anymore. So do you think there's a way that you can help to encourage people to or like let people know more about these libraries?
Yeah, that's a good point, and I think it's a double-edged sword in the sense that I believe clj-ml has everything out of the box. I mean, it's been around for a really long time, and it doesn't need, the only reason you would need to update clj-ml is that if there's some new library that's come out and you want to add support. Otherwise, beyond that, just like Weka, it has, so many classifiers that you're like, do I really need to try 30 classifiers? But that's how it is. So, but I take your point about documentation. I mean, sometimes improving documentation, I mean, just seeing the last commit date sort of gives people the idea that, it's old, it's probably, broken around the edges, which is not true. But I don't know if there's a way to, make it more appealing, and I'm open to suggestions around that.
Is there anyone else who has a question for Kiran?
Actually, I want to add something to that real quick, if I may.
Sure, please go ahead.
So one of the fundamental design principles of Clojure that isn't shared by Scala is that we don't need to update our libraries once they're written. There's a lot of Clojure libraries that are very old and haven't had a commit for 4 or 5 years potentially, and are still extremely useful. And the reason that that works is because Rich made a lot of design decisions very carefully so that he chose very conservative pathways with the language, and the language has not changed them. So you're used to languages like Python or Scala or these other languages where, with Scala, if they update the compiler, then every single Scala library has to change now to use the new compiler. But, and to a lesser extent Java. But with Clojure, it's been backwards compatible for quite a long time. So one of the assumptions that new people have coming into the ecosystem is, man, there's all these libraries that haven't been updated for a long time, just like you said. But I urge you to think you're in a different ecosystem, and some of the design principles of that ecosystem mean that as a library author, I don't have to update my libraries anymore. And I have a few libraries that are quite old, but they're still really useful. So that's another take on that kind of perspective.
Oh, thank you very much for your comment, Chris. I think it's very important to stress that traits of the Clojure landscape of the Clojure library landscape. It's very very important to know that, because sometimes those who are not so fluent in Clojure, we tend to forget that, and I think it's a very important point. I have a question for Kiran, which is also in a way a question for Anthony, because I would like to recycle Sivaram's question and wonder, and I wonder really, is clj-ml and is Geni, I mean, are those projects okay if we use them from a laptop or not? I would ask first Kiran and then Anthony.
So CLJ, I mean, Weka basically is designed for in-core machine learning. It does not really have a distributed component of its own. It has got separate libraries and projects to do that. So that's pretty much the only way you can use it.
Sivaram, is your question answered?
So from what I got from Kiran was that it's the only way, I think, if I understand correctly, he said that the only way to use it is on a laptop or a desktop in an interactive way. Is that correct, Kiran?
Yeah, I presumed your question was more about in-core and out-of-core, but yes, it is. You can, of course, interact with it.
So this may be a very kind of like a newbie question kind of a thing sometimes. And it's part of the, some of you who've been working in data science or machine learning and all this take a lot, you take things for granted, and that's what comes, as an expert, you take it for granted. But sometimes it is these basic questions that trip you up. And it's like, how do you set up your environment? How do you get started on this, on using something? Am I doing the right thing? And this goes to the I think you covered that in the first part, right? Where what is a good use for clj-ml or Weka kind of thing? When should you use it and all that? So it's part of that thing, okay, where, I'm saying, hey, should I even bother to use this if I'm doing work most of my exploration on just using a laptop and I don't have access to, an AWS cloud environment or something like that?
Yeah, absolutely. So you can use it on a laptop. I mean, the GUI tool is just Java minus jar something. And using clj-ml is again just importing one or two libraries depending on what you need. So there is no, as far as I know, there is no native dependency, and it's just this, nothing else.
Anthony, what about Geni?
Yeah, so I definitely understand that Spark has this reputation, right, of being used only for distributed computing. It's only being used for when you have like a massive cluster and when you have like a massive data set and stuff doesn't fit in core, right, and your memory. So based on my experience, that hasn't been the case, right? Like I use Geni every day on the desktop, on my laptop, and it works a lot nicer, at least for me, right? And obviously I'm biased. I've been using pandas a lot. I've been using Dask a lot. For me, the experience with Geni and Spark is a lot better. So yeah, definitely use it on your laptop. And on sort of like getting started, right? Like I think at least we invested a lot of time on trying to make it as easy as possible. So the entire thing with the Geni CLI is that you should just be able to start then and there, right? And to install that, you need 3 bash commands. So download, move it to your path, and make it executable. That's it, a bit like line, right? And then it just starts, and you're good to go. So it's usable on the laptop, definitely.
Thank you very much, Anthony, for
your
Anthony. Answer. I have a question which is also for both. First Kiran and then Anthony. I remember there was some discussion about the license under which Weka is distributed, which is GPL2, if I remember correctly. And there was, if I remember correctly, there was someone who said he or she didn't use Weka because of the license. Do you have an opinion on that, Kiran?
What I've learned is that basically if clj-ml also uses the GPL license, it would make it easier. And I'm happy to change the license if it is as straightforward as that. But beyond that, I'm in no position to comment on whether it makes it easier for somebody to use this or not.
What's the current license for clj-ml, by the way?
I believe it is MIT, but I could be wrong.
Okay. No, because if that's the case, then, okay, this is my opinion. Of course, I'm not a lawyer. That the main problem I personally find in Clojure is that the license is not GPL compatible. I mean, the Eclipse Common license cannot be combined with the GPL. So if somebody wants to start a project that uses the GPL, it has to give a special permission to link with EPL code, which is what I had to do when I started a project, a small one. So I think it's a major nuisance. Personally, I think that if the question there was not to use the GPL, they would have been okay by using, let's say, Apache, which is GPL compatible. But that's just a personal comment.
Okay, so it sounds like it's as straightforward as, even if I don't do it, like anybody can literally fork clj-ml and just change the license field. Like there isn't even a file, it just says MIT license.
Yeah.
So there is, I think if you do not change the code, the Weka code, I think you're free to use it even for a commercial use. Is that not true? As long as you don't change the code.
Well, the GPL is commercial friendly. I mean, you can use it for anything you want. The thing is that the main rule is that if you change the program, you have to allow anyone who uses it to benefit from those changes. That's the spirit.
Right. So the question for clj-ml is there any change to Weka that it's doing?
No, it doesn't change Weka.
In any case, if it's MIT, so it should be compatible with the GPL. Actually, I think the problem is just when one has to build the jar, let's say, given that Clojure has EPL, like Eclipse license, it's a little bit complex to combine your own code with Clojure and with Java, which is under the GPL with class path exception. So that's probably the most tricky part, at least as far as I'm concerned. Is there anyone else with a question for Kiran? Otherwise, we can switch to Anthony again. Okay. So,
yeah, is a question on
sorry. I believe the original licensing comment came from Chris, says Tudur. Perhaps he would like to comment. Yes, Chris.
Yeah. So when I was at NVIDIA, when we used any GPL software in our product, we had to ship the product in a way that would allow any user to rebuild the full product with changes to the GPL section of the software.
Yeah.
So you cannot, we were able to ship, I think in this case it was, oh man, sorry if I'm speaking about things you don't understand, but it was an executable. And so we shipped the specific library as a shared library. We kept it as a shared library, and we shipped a whole build system so that a user could, for instance, rebuild a portion of that shared library and then relink it into the main program. That was one of the things we had to do at NVIDIA. I'm not sure to the extent that we had to ship other source code unrelated to the GPL, and it gets really hairy when you start serving data over the web and you're trying to figure out what portion of your production server system now you have to ship to a user or allow a user to change in some way. And that definition there has changed depending on which version of the GPL you're actually linking to, and kind of a lot of things in there. So the GPL is definitely something where if you're making money with the software, you need to consult a lawyer who specializes in it to tell you what the right way to do it. And the right way to do it may very well eliminate your competitive advantage in your field. So it's something to be very careful of.
Yeah, I think it deeply depends on your business model, definitely. Yeah. So is there anyone else with questions for Anthony? Because
I've got a question for Anthony.
Please go ahead, Tudur.
Yeah, I just wanted to say hello, everyone, and thank you for the lovely presentations. Watching this was really nice, and your moderation is excellent, Leandro. So my question for Anthony, it was really fun to see you play with the REPL and see how much you could get done with so little code. But I'm curious about the DSL, because I saw you write a bunch of G/something functions, and I'm assuming they map to the Scala DSL for Spark. But I was kind of left confused because you were putting things into other things, and is there a way to think about those? What do they take in and what do they take out? And if we have the time, perhaps you can just share your screen again and explain a few of the functions. For instance, G/remove and ML/translator.
Yeah. Okay. So if I could share my screen again. I think, yeah. So, yeah, definitely. With the G this is just shorthand for this guy, right? Just 01 Geni.core require as G. And there's ML, and there are like 4 namespaces, right? There's RDD, and there's streaming. And this all corresponds, all of these correspond to the 4 main Spark libraries, modules. So core refers to Spark SQL, ML refers to Spark ML, there's Spark RDD and Spark streaming. And what you get with a lot of these is like transform, select, with column, all of those stuff are straight out of Spark, right? So if you've got experience working with Spark datasets, they are, yeah, they're just straight off translations. So these really are just Spark, wrapping Spark methods plus some other extra stuff. For example, like Spark doesn't have remove, right? So you'd have to do filter and then something like not or something like that. That's what you would do in Spark. But then Clojure does have remove, so I added remove, right? Yeah, does this answer your question, or was there something that was particularly confusing for you that we could go through, perhaps?
Yeah, so I think it addresses the question really well. But for instance, you're doing the piping thing, and you're piping from invoices to remove, to select, transform.
Yeah.
So just from that, I'm assuming that invoices take some data type and return the same data type.
Yeah.
And that happens downwards. Is that correct?
Yeah, that's right. So if I get rid of all of that, so invoices is just another Spark data set, right? And then select is just another Spark data set. And yeah, so this is meant to resemble the kind of method chaining that you have in Scala. and which I think works very well as well in Clojure.
So is this data set immutable like it would be in Clojure?
So actually what happens, what's interesting in Spark is that this thing gets recomputed every time. Yeah, so there isn't absolutely no mutation happening here. Yeah, so if you're doing all of these stuff, actually every time I call it, it gets recomputed. So it's actually going to read the CSV, it's actually going to rename it. What happens underneath is that it creates a computational graph until I have an action. So show is an action or count is an action. But otherwise, this is, I think, what Haskell people call a thunk, right? It's just a computational graph. Like it's a plan to do something. As soon as you say show, then it does something. And you can do like cache, which just means like, okay, so actually save it so that the next time it's faster that happens. So I'm guessing, yeah, I guess it's kind of a long-winded way of saying that I guess definitely all the Spark peculiarities, all the Spark features, all the Spark properties are here, right? And you kind of have to understand the how Spark works in order to be quite effective in this. And that's also by design, right? Because just like how you know, in Clojure sometimes you need to understand how Java works, and I think you know, if you're leveraging a particular ecosystem, you know, you probably want to understand how Spark works as well.
Yeah, thank you for the great reply. That was really enlightening. Yeah, thanks.
Thank you, thank you.
Just curious, is there anyone else who wants to ask a question to Anthony? Just curious.
I have two questions if we have the time.
Just say I, so I know how many questions are there. Just count yourself, please. It would be nice. Okay, one. Is there anyone else besides Kiran? So if I see if that's the okay. If that's the only question, then we can take that last question and then officially finish, because we are already past time, and at least officially. Of course, we can stay longer if we wish to, but I would like to avoid forcing someone to stay if he or she doesn't want to. So just to be sure, Kiran's question is the only question we have left, right? Okay, I don't hear anyone saying anything, and I don't see any virtual hand raised. So
I have a question for Daniel, but maybe, I don't know, is that something for later, perhaps?
If it's only two questions, maybe we can just stretch it a little bit longer, and that's it. Yeah. So it's okay. Yeah, please, Kiran, you were the first one. Please go ahead.
Sure. Anthony, so I have actually two questions, and I'll try and make it quick. The first one is that there have been other Spark wrappers in Clojure. So what was your motivation for writing this? And the second question is, how would you advise somebody to use a non-Spark pipeline versus a Spark pipeline? And you've shown clearly that it is fast enough, but there would obviously be some trade-offs in using Spark in a single machine. Let's say you've got a lot of RAM and you can do stuff really fast. So when would you advise somebody to use a regular Clojure pipeline versus something using, say, your tool?
Okay, so I'll try to reply very quickly as well. So the first question is, there are other Spark wrappers. So the ones that I know of is Sparkling, Flambeau, and PowderKeg. And actually there's Sparkplug as well, right? The main thing is that all these four libraries, they target Spark RDD APIs. So that's the lower level Spark. So you don't have this nice Spark SQL interface, which I think, you know, so I used to work with Scala Spark a lot for about 2 years. you use Spark SQL for 95% of the time, and then the rest, it's a combination of ML, RDDs, yeah. So they're missing out the most important part of the Spark ecosystem, I feel, Spark API. And it's not to say anything bad, like I think Spark SQL is, they got released after these libraries were actively being worked on. So that would be the answer for question 1. And second question is about, sorry, can you remind me, is that like, when would you use this? Like in what situation? That...
Yeah, and when would you use, say, a non-distributed pipeline? Is there a case that you believe that's useful, or you would always stick to this?
No, actually, like everything I showed you is not. It happens on a single desktop. It's not a distributed cluster at all. So Spark has these modes, right? There's distributed mode and there's local mode as well. So no, it works on your laptop, it works on the desktop, it works on the cluster. Same code, like no modification at all, right? And actually with RAM, like I found that RAM usage with Spark is a lot better than Pandas. So I don't see that might be an issue. One thing that could be an issue is the fact that you're relying a lot on the Spark built-in functions. It's very rich. You can do a lot of things there. You can get a long way just using Spark built-in functions. But then when you want to do custom stuff, then you need to either drop down to RDDs, which is not nice to work with, or you want to collect and then go to Clojure and do your own thing. Yeah, so that's probably could be an issue there.
Okay, thank you.
I have something to add there real quick.
Please, yeah.
I think, so one is there is a consideration that I found with Spark in that it generally makes heavy use of disk in various ways that you may not necessarily predict. And I've had it eliminate the disk space on my machine when I was playing with it, potentially carelessly, but it does write a lot to temp files when you're doing various things. So if you're going to use it in like a Kubernetes situation, you just got to kind of think of how you're going to mount your containers and that kind of thing so that it has disk space available to it. And that very well could be how I misconfigured it or lots of other things. But the naive configuration of Spark data frames can be disk IO intensive. But that I think is something you would not hit on a laptop, and I don't think it's a consideration for the desktop. That's just something you should kind of know might happen under the covers. The other thing was, I think that there's, just to add on to what Anthony said, when you want to do custom stuff really before or after Spark, I think that's a place where we can figure out really easy ways to convert Spark data frames to tech data sets back and forth. And the tech data set sits much closer to Clojure's kind of language design philosophies. I think the Spark data frame is really amazing, and I really enjoyed the talk. And I think it's going to work in a lot of situations with really larger data where the data set abstraction that I built might struggle. But when you want to get into really custom things, or you're building a server where you want to kind of mix data set processing in with lots of other things, I think there's space to have better bindings between the Spark data frame and tech.ml data set. And then I feel like you have all the options open to you at that point.
I think I would really need your help, Chris, to do the zero copy path.
I think, well, is there a way, how in Spark, when you collect, what's the result of that? Is that like a set of arrays in Java and some metadata? Is there a way to get it to that level?
So when you collect, you get a Scala sequence of Spark rows. So Spark rows is a bit like case classes. It's just like structs, and then it's a Scala sequence. Yeah.
Is there any way to collect to columns and not go all the way to rows?
to columns and not all the way. Sorry, what do you mean by that?
Well, tech.ml dataset stores data in column-wise fashion. So is there a way that I could collect to contiguous columns instead of to row-wise definitions?
So I guess you can select the columns and you can collect it, but I don't know if that's what you're looking for.
That probably would work. I mean, if and then take that and make a Java array out of it, it shouldn't be horrible.
Right. Yeah. But yeah. Yeah, it could be possible. Yeah.
It really depends. Like, it really depends on how hard it is to transform between a column-wise and row-wise definition with Spark data frames. Okay. That's the question.
I think I'll ask you and private on some tips on how to do that, because I've been chatting with Daniel as well that this would be a very good bridge between the two libraries.
I agree.
Okay. Is there any other question? Okay, I think not. So thank you very much, everybody, for participating in this session. We are really looking forward to the consequences of your private exchanges, probably in a upcoming talk. That would be really welcome and nice. So I think we can officially end this event. Many of us will stay. Of course, no one is forced to stay if he or she doesn't want to. But again, we thank everybody for participating and coming today and hearing these very interesting talks about machine learning in Clojure. And we really are looking forward to see you in our next event. Thank you very much. And that's it.
Thank you.
Thank you.
Thank you very much. Nice work.
So, yeah. So we are officially done. So now it's discussion time.
May I ask a question to Daniel?
Come on, it's too late now. Sorry.
Hey, just quickly before you continue, this was so great. Absolutely amazing stuff. Thank you for the speakers. I can't wait to get back home to my machine and play around with these libraries. And also thanks for the moderation. These are so nice. But yeah, I need to go now. So bye bye. See you soon.
Are these talks and the presentations and the slides and notes or code and all that available somewhere?
I'll push mine to a repository. And how should we share this, Daniel and Leandro?
Ask Daniel.
Yeah, so recently we have been having some chats about having like maybe a central place for tutorials. So that can be one way. We have a GitHub organization where everybody can put their projects if they wish to put them there. But personal repos also work, I guess. To me, it may take a little bit more time to complete the tutorial, and I wish to share it there under the Scicloj GitHub organization.
I assume we can share links in the Zulip chat as well.
Yeah, I'll share my presentation on the Zulip chat.
May I now ask a question to Daniel? Yeah, so Daniel, what is it that you use for presenting? Is it NoteSpace?
Yes.
Is that like a drop-in replacement for the REPL, or like how do you use NoteSpace?
Yeah. Should I share my screen? Just
yeah,
for
I think
a moment?
Yeah.
Sure. The dog is barking. Sorry for that. So I will share here.
I thought you had a cat.
Yeah, there are cats too.
Ah, okay. So you have both. Okay, cool.
Yeah. So maybe just really briefly, let us look into what node space is about. And yeah, to me, it has been fun to combine it with the tech stack and Fastmath. So let us maybe have a new namespace so that we can look into a clean situation. So here is a namespace. And the idea is to keep working at your editor and REPL, and the browser view will be affected by what you do there. And I will have to ask the dog to be quiet for a moment. I'm sorry. Oh, here.
Yeah.
She's calm now, I hope. Yeah, so here we begin. Yeah, we have an empty namespace and some empty view at the browser, and we can start adding different kinds of Clojure elements, anything that we can have in a Clojure namespace. So one of them can be a string that renders as markup, something like that. And we can update the view, and we can see in the view that we have it in the browser. But we keep working at the REPL and editor, right? So I have some key binding to a certain function call that makes it work. And we can have different kinds of nodes. So for example, we can have let us add it as a dependency. Maybe here. So we can add a node of kind hiccup that would just render differently, since it is something that we wish to be rendered as hiccup. Yeah. So now we render some hiccup.
Am I right in saying that there's no hot code reload? So you have to manually refresh it?
So I never touch the browser.
Yeah.
And the browser state is updating by a WebSocket connection.
Mm-hmm.
And sometimes I update the whole namespace, and sometimes I ask to update a certain node. For example, this one, I call a Clojure function by a certain key binding, and then it updates. Does it make sense?
But only for that form.
Yeah, and it depends on the semantics of what you wish. You may ask to update everything or update a certain form. And we are actually thinking about what kinds of semantics would be useful. And it is in many senses, it is inspired by Oz, which is a more mature, more complete library and tool that has a better user experience, I guess. And there, Christopher Small has been experimenting with different semantics of how the view updates. And we are keeping this experiment and would love to hear about what you may think could be useful.
So it sounds to me like you can use this as a REPL replacement, right? So like you don't need to touch the REPL, and then you just let the, I mean, you need to touch the REPL, but then you see the code being evaluated on the browser instead of on your text editor.
Yes, yeah. Maybe let us call it an enhancement of the REPL. You keep using your usual tools, and it is almost agnostic to your editor and REPL setup. It just adds an additional view.
And it'll render plots, graphs, and everything beautifully as well, right?
Yeah, so let us maybe add tech.viz, the library by Chris. This one maybe. And so we can have with histogram maybe of some random numbers, and something like this. So what is it? If we do not specify the type of the thing that we've just built, then let us see how it renders. So so it is a spec of the Weka format. And then we can say, okay, we wish this node to be of kind Weka. And then update the view. And then we have this nice rendering of TechViz by Chris. Does it make sense?
Oh yeah, it does. It's awesome.
Nice. Yeah, and
it's really awesome. Really, really awesome.
And we hope, I think, that it can be kind of compatible with Oz. So you could be writing your notebooks in Oz and then render them in NodeSpace, just with a different user experience. But there are some differences at the moment. And let us discuss what would be useful if you wish.
Daniel, this is really awesome. Perhaps you can comment on how this is similar or different from Gorilla REPL, and what made you build this?
Yeah, so Gorilla REPL is really maybe one of the first, probably the first notebook written in Clojure. It is a project written by Johnny Hudson, and it is written in Clojure and JavaScript, and it provides a full client-side experience where you can edit and manipulate your notebook in the browser. And it has really neat ideas about creating composable views of your data that we cannot go into in the moment, but there are really, really conceptually beautiful ideas there about the way you visualize Clojure data structure. And Gorilla REPL has stopped being under development, and now there is a new project called PingGorilla by our friends Andreas and Florian. And PingGorilla is actually a huge ecosystem of Clojure libraries for a very much complete experience of a notebook-like tool in the browser, and it is written in Clojure and ClojureScript. And there is a lot going on there, and the central notion is having a really decent browser experience. We have been using some parts of PingGorilla inside NodeSpace, just as a rendering engine. But other than that, NodeSpace is just a thin layer compared to the huge thing that PingGorilla is.